By the year 2026, it is undeniably clear that humanity has perfected the complex art of building physical things. Mega projects that once took decades now move faster than ever. NASA's Nancy Grace Roman Space Telescope, a $4.3 billion machine designed to map dark energy, is scheduled to launch 8 months ahead of schedule. This precision extends to consumer devices like the Fitbit Air. By removing the screen and focusing entirely on internal sensors, engineers created a 12-gram tracker that is almost imperceptible on the wrist. Our hardware is becoming more reliable, streamlined, and efficient, but our digital world is currently struggling with a deep-seated crisis of stability. Google recently shut down its Pixel Studio app after less than 2 years. It was an exclusive image generation tool for their flagship phones, but it was abruptly discontinued in favor of their broader AI platform. When premium software features disappear shortly after launch, it alienates the people who paid for them. It makes the entire brand ecosystem feel temporary. This fragmentation is driving users toward unified platforms like Gemini. People are looking for a single, stable interface, rather than a collection of specialized apps that might be deprecated at any moment. This lack of long-term stability in apps reflects a deeper issue. The invisible codebases that run our world have become so complex that they are increasingly difficult to maintain and secure. Much of our infrastructure relies on legacy code like FFMPEG, a multimedia framework that processes video and audio for billions of devices worldwide. Human experts have scrutinized this code line by line for 20 years, yet an AI agent recently scanned it and found 21 hidden vulnerabilities that human auditors had completely missed. Some of these bugs date back to 2004. One specific flaw in memory management could allow an attacker to take full control of a system by sending it a single malicious file. These flaws stayed hidden because modern codebases have reached a scale that exceeds the limits of human observation. As these digital foundations grow larger, relying solely on human review creates a backlog of undiscovered risks. We're entering a phase where security must be as automated as the code it protects. But using AI to defend our software introduces a new problem. AI models have their own unique structural weaknesses. Microsoft researchers recently highlighted this when they found a credential theft risk in Claude Code, an AI agent used by developers on GitHub. The issue is a vulnerability known as prompt injection. Large language models receive operating instructions and data in a single stream, without barriers. Because the AI cannot distinguish a system command from raw text, an attacker can hide a string that tells it to export private AWS keys. This isn't a bug in the code that can be easily patched. It's an architectural limitation that can turn an AI assistant into a security liability. Anthropic released a patch within 4 days, adding filters and sandboxing. However, since prompt injection is tied to how language models function, these are defensive measures rather than a permanent solution. We are now in a persistent cycle where defenders use AI to find vulnerabilities, while attackers use AI to find ways around them. The shift toward unified platforms like Gemini and simple, screenless hardware like the Fitbit Air reflects a growing desire for stability and reduced complexity in a world where software is increasingly volatile. Within 18 months, an AI-audited certification will likely become the standard requirement for any code deployed in a professional environment. Whether you are choosing a consumer ecosystem or managing a corporate server, a zero-trust approach is becoming the necessary baseline for handling the complexity of modern technology.